Hello, and welcome to the Virtual Training Company's Advanced Java Programming with Java 7. I am David Sines, and I will be your instructor for this course. In this course, we will be learning about the following areas in the Java programming language. We will be reviewing Java fundamentals, such as data types, Java language constructs, and I/O. We'll also be taking a look at packaging and distributing Java applications. You'll be learning how to package your class files and distribute them. Miscellaneous enhancements. Increase your knowledge of how to avoid common problems with far more powerful enhancements to data structures than their counterparts in other language. Assertions. This chapter will introduce Java assert statement, which specifies assertions that can be used to enforce preconditions and postconditions. Regular expressions. I'm going to be showing you how easily you can use the power of regular expressions in your Java applications. The Java collections classes. Here you will learn what collections are and how they can make your job easier and programs better. You'll learn about the core elements, interfaces, implementations, and algorithms that comprise the Java collections framework. Generics. Generics add stability to your code by making more of your bugs detectable at compile time. Advanced I/O. We will build upon your knowledge of Java's I/O. Enhanced I/O. JDK 1.7 enhances support for file I/O via the so-called I/O NIO.2 classes. Logging API. We're going to be learning how to use the logging API in Java programs instead of just doing debug out print line statements. Networking. How to use the Java Net package to access the internet and do some network programming, such as client to server. Threads and concurrency. We will take advantage of Java's powerful concurrency API with threads, remote method invocation, or RMI. We're going to be learning how to create distributed Java technology-based applications. Java Database Connectivity, or JDBC. We'll be looking at how to access the database with Java's JDBC API. I look forward to your advanced Java programming. In this video, we will take a look at and review Java fundamentals. The ability to create and compile Java source code files into running applications is the first skill acquired in becoming a Java programmer. This involves creating packages for your classes and interfaces and importing classes and interfaces from other packages. It also involves creating a properly formed main method and using it to access command line arguments. In addition, you learn how to create valid identifiers and work with primitive types. These are the fundamentals of Java programming. Coding standards. The code conventions for the Java programming language contains the standard conventions that Sun and Oracle follow and recommend that others follow. It covers file names, file organization, indentation, comments, declarations, statements, whitespace, and naming conventions. Class name. The first letter of each word is capitalized. Examples are car or business object name. Function name. The first letter of each word except the first word is capitalized. Examples as get age or set height. Variable name. The first letter of each word except the first word is capitalized. Examples are age or brain size. And constant names. Every letter is capitalized and underscores are used between words. Examples are max height and max age. Flow of control repetition statements. Important control flow statements from which we can build patterns and frameworks. Control flow statements supported by the Java programming language for decision-making, looping, and branching statements that enable your programs to conditionally execute particular blocks of code. Recall the for loops, while loops, and if statements, switch, and case statement. Things to keep in mind. Reserved words, variable scope, primitive data types, objects, and arrays are the fundamental building blocks of the most advanced programs. Let's add to our repertoire of skills and knowledge advanced APIs and concepts. Welcome to this lesson on the Java development environment. This is going to facilitate you for your Chapter 1 reviewing Java fundamentals. What I'm going to be introducing to you guys today is the Java IDE, Eclipse-based IDE. This is going to be facilitating you with the development, execution, and packaging of your Java applications. So the first thing I want to show you is that when you open the Java Eclipse IDE, you're going to have to create a project. Every chapter, we're going to be creating projects and we're going to be developing all of our assets and all of the code for the project into this Eclipse-based IDE. So we want to go over here to File. We want to say New. And when you say New, you're going to have a complete list of all the available projects that come with the Java Eclipse IDE. Any one of these projects will bring certain assets with it to help Eclipse track and be able to compile the code that's part of the project. We can see here Enterprise Application Project, Dynamic Project, EJB Project, and Static Projects. When you want to create a simple Java project, you're going to be clicking on the project, and here you're going to get a wizard that's going to be automatically selected to Java project. If it is not selected, you can scroll up and down and look for this particular wizard here to create a Java project. When you click Next, it will bring you here to this screen called the Create a Java Project. As you can see, it's going to ask you for the project name, which you can name whatever you want. Try to give it a name that you can remember what the project is being used for. You're also going to have a default location. This can be anywhere on your drive. You can browse where you want this location of your project. Here we have the Java execution environment, or the JRE, which is the Java 7 execution environment. We're going to leave the defaults when creating our projects. I already went ahead and created our first project here, Chapter 1, Review Fundamentals. So let me explain a little bit about this project structure. First of all, as you can see here, it's got a little J on the side, meaning that this is a Java project, which Eclipse recognizes as a project that it can compile. As we open up the project, we're going to notice that there's a source folder and a JRE system library, which we chose when creating the project. This source folder is actually a real folder on your hard drive, which is where your Java files are going to be stored. The default package is where I'm going to be storing my first class, which I named in this case Hello World. And when I double click it, it's going to be opening up, and as you can see, the outline came up, which specifies the structure of the Java class. I have a simple here, Hello World. So what I'm going to do to compile the class is I'm simply going to right click on it. I'm going to scroll down here to Run As, and I'm going to say Java Application. Okay, as you can see on the console, Hello World comes out, which is the result of our main function in our Hello World Java class. Alright, I hope this helps you to begin developing on Eclipse IDE, and from now on we can begin to review the fundamentals. Thanks. In this video, we will review the data types available within the Java programming language. You should already have had exposure to these data types in the VTC course Java 7 Language Basics, so we will quickly be reviewing them. First, we must distinguish data types in Java. There are two types of data types in Java: primitive data types and class object types. A Java primitive type is predefined by the language and is named by a reserved keyword. Primitive values do not share state with other primitive values. The 8 primitive data types supported by the Java programming language are byte, short, int, long, float, double, char, and boolean. We know that byte, short, int, and long are integers. Float and double are single precision floating points. Char is a Unicode character, and boolean is 1 bit of information. There are 2 good reasons to use primitives instead of objects where possible. Number 1 is clarity. By using a primitive, you are making it clear that a null value is not appropriate. Number 2 is performance. Using primitives is often much faster. Okay, let's take a look at Java class object types. As you can see here, when an object is required to represent the primitive type and hence plug into the object hierarchy, we can use these object types. The wrapper classes are used extensively with collection classes in the Java util package and with classes in the reflection package. Here we have some primitive data types represented as objects in Java: byte, short, integer, long, float, double, character, and boolean. Here we have our class types that have not been initialized or given any value. We must be careful to always initialize object types to prevent null pointer exceptions in our programs. There are three different ways to initialize our objects: using a string, a primitive type, or the method value of. Let me demonstrate this. Allocating new memory, initializing by the value of a string. We're going to create a new short object using the primitive data type short. And we're also going to create a new integer object using the value of method. Now here's a performance tip. Classes and objects have some overhead associated with them. They offer generality at the cost of inconvenience in digging out the value. And there are some space costs as well. Here's an advanced performance tip. When the need arises to use your value as an object, use this method, value of, because it uses a pool of objects which for performance reasons is preferred over to allocating memory using the new object. Now let's take a look at atomic classes. With Java 5.0, additional wrapper classes were introduced in the Java util concurrent atomic package. These classes are mutable and cannot be used as a replacement for the regular wrapper classes. Instead, they provide atomic operations for addition, increment, and assignment. Atomic variables which can help us to write lock-free and wait-free algorithms which were not possible prior to Java 5.0. The atomic wrapper classes and their corresponding types: atomic integer, atomic long, atomic boolean, and atomic reference. We will discuss these atomic wrapper classes in greater detail in Chapter 12, Threads and Concurrency. Now let's run our program. This concludes our discussion of Java data types. In this video, we will review the Java string class available within the Java programming language. You should already have had exposure to the Java string class in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. A Java string contains an immutable sequence of Unicode characters. Unlike C or C++, where string is simply an array of characters, a Java string is an object of the class java.lang. String is immutable, that is, its content cannot be modified once it is created. For example, the method toUpperCase constructs and returns a new string instead of modifying its existing content. Okay, let's review string initialization mechanisms. There are two main ways to create Java strings. One is by creating a string literal. String is associated with string literal in the form of double-quoted text such as hello. You can assign a string literal directly into a string variable instead of calling the constructor to create a string instance. The other way is to explicitly create a new object in memory. Here's an advanced hint. The API itself discourages the use of the string constructor. Unless an explicit copy of the original is needed, use of this constructor is unnecessary since strings are immutable. Use literals where possible to obtain the best performance. Let's look at using the string literals in switch statements, which is new to Java 7. Before Java 7, only integer values were valid arguments in a switch statement. It is not uncommon to need to make a decision based on a string value, and the use of a switch statement to perform this task can simplify the series of if statements that would otherwise be needed. This can result in more readable and efficient code. Let's add our case here. Now let's run our program. This concludes our discussion of the Java language string class. In this video, we will review the Java string buffer class available within the Java programming language. You should already have had exposure to the Java string buffer class in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. Java provides the string buffer and string classes, and the string class is used to manipulate character strings that cannot be changed. Simply stated, objects of type string are read-only and immutable. The string buffer class is used to represent characters that can be modified. The significant performance difference between these two classes is that string buffer is faster than string when performing simple concatenations. In string manipulation code, character strings are routinely concatenated. Using the string class, concatenations are typically performed as follows. Creating my string object, initializing it. Now let me concatenate. If you were to use a string buffer to perform the same concatenation, you would need code that looks like this. Now I will initialize my string buffer. Now developers usually assume that the first example above is more efficient because they think that the second example, which uses the append method for concatenation, is more costly than the first example, which uses the plus operator to concatenate two strings. The plus operator appears innocent, but the code generated produces some surprises. Using a string buffer for concatenation can in fact produce code that is significantly faster than using a string. Performance-wise, string buffer is faster when performing concatenations. This is because when you concatenate a string, you create a new object internally every time since string is immutable. Let's run a small program to stress test string buffer versus string and the plus concat operator. We will do straight string concatenation versus string buffer concatenation. In a big loop, I just add one character to a string and a string buffer. So as we can see here, I'll be concatenating strings, and here I'll be doing it with string buffer. Let's see our results. As we can see, the string buffer already finished, while the string continues to append. Look at the great time difference. This makes it clear I should never use plain string concatenation in big loops. Of course, if you're just concatenating a few strings once in a while, this doesn't matter. String buffer concatenation is significantly faster than string concatenation. Obviously, string buffers should be used in this type of operation when possible, whenever you're looping over big data. If the functionality of the string class is desired, consider using string buffer for concatenation and then performing one conversion. This concludes our discussion of Java string buffer class. In this video, we will review arrays, available within the Java programming language. You should already have had exposure to arrays in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. An array is a group of variables, called elements or components, containing values that all have the same type. Arrays are objects, so they're considered reference types. As you'll soon see, what we typically think of as an array is actually a reference to an array object in memory. The elements of an array can be either primitive types or reference types. To refer to a particular element in an array, we specify the name of the reference to the array and the position number of the element in the array. The position number of the element is called the element's index or subscript. Here's an example of an array with primitive types. We'll call it C. Here's our primitive type array. Here's an example of an array with reference type. Now let's look at different ways of creating and initializing an array. First, let's look at just creating an array with a certain size. The elements of the array do not have a value at this point. So here we are declaring an array. And then here we create the new array object. We can also use an array initializer. You can create an array initializer and initialize its elements with an array initializer, which is a comma-separated list of expressions called an initializer list, enclosed in braces. Let's see how this works. So here, as you can see, we have the array. Instead of giving it a size, we're going to actually put values in it. In this case, the array length is determined by the number of elements in the initializer list. So the length of this array would be 1, 2, 3, 4, 5 elements. Now because we start at 0, when we loop over it, we'd actually begin with 0, 1, 2, and 3. Now let's access the values of the array elements. First, we're going to create a for loop with a counter that starts at 0. We're going to make it less than the array's length. And we're going to increment the counter every time it comes around. We're going to format the output so that it's readable using the printf method. Let's run our code real quick and see what happens. Okay, here we have the position, and then we have the value. So at position 0 is 10, at position 1 is 20, so forth. Another way of accessing the values of an array is using the enhanced for loop, or for statement. The enhanced for statement iterates through the elements of an array without using a counter, thus avoiding the possibility of stepping outside the array. Here I have code already written. We have a system.out printf with headers, position, and value. This is the enhanced for loop. It would look much different. As you can see, the expression here actually creates this variable number with the value of the element in the next position. I'm going to format the output. And output the number. Let's comment this out. And now let's run our program. As we can see here, without the need to access the position, this expression actually gives us the values. The enhanced for statement simplifies the code for iterating through an array. Note, however, that the enhanced for statement can be used only to obtain array elements. It cannot be used to modify elements. If your program needs to modify elements, use the traditional for statement, which is the counter-controlled for statement. This concludes our discussion of Java arrays. In this video, we will review passing data types to a method, available within the Java programming language. You should already have had exposure to passing data types to a method in the VTC course Java 7 Language Basics, so we will quickly be reviewing it more in depth. Two ways to pass arguments in a method calls in many programming languages are pass by value and pass by reference, also called call by value and call by reference. When an argument is passed by value, a copy of the argument's value is passed to the called method. The called method works exclusively with the copy. Changes to the called method's copy do not affect the original variable's value in the caller. When an argument is passed by reference, the called method can access the argument's value in the caller directly and modify that data if necessary. Pass by reference improves performance by eliminating the need to copy possibly large amounts of data. Unlike some other languages, Java does not allow you to choose pass by value or pass by reference. All arguments are passed by value. A method call can pass two types of values to a method: copies of primitive values and copies of references to objects. Objects themselves cannot be passed to methods. When a method modifies a primitive type parameter, the changes to the parameter have no effect on the original value in the calling method. Here's a pass-by value example. The printed value will be 2.0 no matter what happens inside the method change me. So here I declared my value and my variable that I'm going to be passing to my method change me of type double. As you can see here, the value is 2.0. It's going to be changed here in the method change me to 345.0. This has no effect on D outside of this method because the double value is being passed, or in other words, being copied to the method. The value is never passed back. It's only changed within the method because it's actually given a copy of the variable. Let's run it and see. As we can see, D equals still 2.0, even though it was passed to the method change me. It was never changed in the main method. Now let's do a pass by reference example. Here we have a car object. Our car class that we will use to illustrate the call by value of the object reference. The car object has an attribute of speed of type double with getter and setter methods. Now let's create a new car and set the speed to 65. So here I have my new car. Now let me set the speed to 65. Now let's try the method change car parameters and pass a Lamborghini to it. I already have it here waiting for us. The system.out.println is going to access the method getSpeed, and we're going to see what the value is. The method change parameter gets the car object and is going to change the speed to 200. So it began at 65, and when it's passed to the method, we're going to change it to 200. Let's see what the output is. The code prints out 200. Why? Because the Lamborghini was a pointer to the object car. The Lamborghini got passed by value into the method, so a copy of the pointer got passed into the method. But a copy of the pointer still points to the same object, the Lamborghini. So changes to the Lamborghini in the method are felt outside the method as well. Let's try another example using the method changeCar, which tries to create a new car and change the value passed into the method. Here's the method changeCar. We're going to pass in our Lamborghini object, and when it arrives here, we're going to actually use this reference by first creating a new car, setting the speed at 75, and then using this reference here, we're going to add the new car to it. And we're going to see that it does not affect the car outside this method. Let's run it and see. So here we have the Lamborghini. We pass it into the change car, try to set the speed on the new car, the Ford, to 75, and actually set the Ford car as the Lamborghini car that was passed in. Now the question is the original Lamborghini object now a Ford outside of the method? No. Inside of the change car, we changed the original pointer to a new pointer, but the original pointer was passed by value. So changing the pointer within the method has no impact on the original pointer outside of the method. This concludes our discussion of Java passing data types to a method. In this video, we will review constructors and initialization, available within the Java programming language. Each class you declare, you can provide a special method called a constructor that can be used to initialize an object of a class when the object is first created. In fact, Java requires a constructor call for every object that's created. Keyword new requests memory from the system to store an object, then calls a corresponding class's constructor to initialize the object. A constructor must have the same name as the class. By default, the compiler provides a default constructor with no parameters in any class that does not explicitly include a constructor. When a class has only the default constructor, its instance variables are initialized to their default values. If no user-defined constructor is provided for the class, the compiler initializes member variables to its default values. Numeric data types are set to 0, character data types are set to null, reference variables are set to null as well. In order to create a constructor, observe the following rules. Its name has to be the same as the class. It should not return a value, not even void, because it's not a method. Let's create our constructor. Let's create some instance variables. And now let's initialize the value of these variables. Let's give the integer a value of 5. Without the constructor, the numeric data types are set to 0. The cars are set to null or empty, and the reference variables are set to null. But by having the default constructor, our variables will always be initialized. Let's talk about constructor overloading. Constructor overloading is a technique in Java in which a class can have any number of constructors that differ in parameter list. The compiler differentiates these constructors by taking into account the number of parameters in the list and their type. Example of valid constructors for a class are By using this constructor, we can initialize the int value by passing in a value when the object is created. We can do the same for the object. As you see here, we have our default constructor, our constructor that just initializes X, and another constructor that initializes demo. We can have a constructor that initializes all three variables or none. This concludes our discussion of constructors and initialization. In this video, we will review Java inheritance. Inheritance is the capability of a class to use the properties and methods of another class while adding its own functionality. The object class is the highest superclass of Java. All other classes are subclasses inherited from the object class. The object class includes methods such as clone, equals, copy, finalize, getClass, hashcode, notify, notify all, toString, and wait. This class here, demo, is implicitly inheriting from object. Here are the object's method that it inherits. Clone, equals, finalize, hashcode, toString. Here I created a shape class, a square class, and a circle class. Let's take a look at each of these classes. Here I have a shape class that specifies a draw, an erase, and a print method. The circle and the square class assume or inherit all the properties of the shape class and can now add its own properties and methods as well as override existing methods, draw and erase. We do this by using the keyword extends. Overriding means creating a new set of method statements for the same method signature. So here we have void erase. If we take a look at shape, we have the same void erase. In the shape class, there's no implementation. But when we look at circle, it adds its own implementation. The base class shape establishes the common interface to anything inherited from shape. That is, all shapes can be drawn and erased. The derived classes override these definitions to provide unique behavior for each specific type of shape. In this case, we will override the method draw of the shape class in the circle class and provide unique functionality. So let's override print. Let's take a look at this error. It says cannot override the final method for shape because it's a final method. Here we can see that overriding the print method causes an error and will not compile because it uses the final keyword to prevent overriding the print method. There's the final keyword. But what we can override is the draw method. Let's demonstrate the usefulness of inheritance by running an example which chooses the correct shape based on the conditions of a switch. As we can see here, we were using the string to switch. And in this case, it chose to create a new shape object and execute its draw method, which prints out correctly shape. Let's change it to circle. Here we have the reference to shape, which all the classes use when they're created. This time we see that by using circle, it created the circle class, but actually cast it back to its parent class shape, and then polymorphically call the draw method. And correctly called draw circle. This concludes our discussion of Java inheritance. In this video, we will review abstract classes. You should have already had exposure to abstract classes in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. Abstract classes and methods force prototype standards to be followed, or in other words, they provide templates for other classes. Here we have the keyword abstract. Because they're used only as superclasses in inheritance hierarchies, we refer to them as abstract superclasses. These classes cannot be used to instantiate objects, because as we'll see soon, abstract classes are incomplete. Subclasses must declare the missing pieces to become concrete classes, from which you can instantiate actual objects. Abstract classes are also called superclass, and they are more general than its subclasses. The superclass contains elements and properties common to all of the subclasses. Often the superclass will be set up as an abstract class which does not allow objects of its prototype to be created. In this case, shape-based abstract class, only objects of the subclass are used. The actual shape-based class is never used. You make a class abstract by declaring it with the keyword abstract. An abstract class normally contains one or more abstract methods. An abstract method is also one with the keyword abstract in its declaration. Abstract methods are methods with no body specification. Subclasses must provide the method statements for their particular meaning. If the method was one provided by the superclass, it would require overriding in each subclass. And if one forgot to override, the applied method statements may be inappropriate. Classes that can be used to instantiate objects are called concrete classes or subclass. Such classes provide implementations of every method they declare. Some of the implementations can be inherited. For example, we could derive the concrete classes circle, square, and triangle from abstract superclass shape. We will make circle a subclass or concrete class of the superclass shape base, which is abstract. We will first use the keyword extend to create the relationship. Following the extends keyword follows the name of the parent class which we will be extending or inheriting from. Eclipse asks us to add the unimplemented methods from the shape-based class, which are abstract. We will do so. We'll add our own implementation. To both methods we just overwrote. Now let's look at the keyword final when added to a class. Final classes cannot be superclasses. A final class that is declared final cannot be a superclass. Classes cannot extend a final class. All methods in a final class are implicitly final. An example of this is the string class. Here I have a shape-based final class. But as you can see here, I use the word final, a keyword, to be able to distinguish this as a final class. Now what happens when I extend my class circle from shape-based final? As we can see, I get errors. It says the type circle cannot subclass the final class shape-based final. So whenever we have a class that we do not want it to be inherited by any other class, we can use the keyword final. Now, just like in our previous example, we can test and see that here we have an error. Because shape-based class, being that it's abstract, cannot be instantiated. Only its subclasses circle and square can actually be created by the new operator. This concludes our discussion of Java abstract classes. In this video, we will review Java interfaces. Interfaces are similar to abstract classes, but all methods are abstract and all properties are static final. Interfaces can be inherited so you can have a sub-interface. Java does not allow multiple inheritances for classes. An interface is used to tie elements of several classes together. As you can see here, we have an interface called taxpayer. Interfaces are also used to separate design from coding, as class method signatures are specified but not their bodies. This allows compilation and parameter. The interface specifies what operations a class must permit other objects to perform, but does not specify how the operations are performed. So each method here has to be given an implementation by whatever class actually implements this interface. Software objects communicate via interfaces. A Java interface describes a set of methods that can be called on an object to tell it, for example, to perform some task or return some piece of information. For example, this operation would be pay taxes. Let's look at the code and let me explain. Here we have a class called business, which is used as a base class for all the different types of businesses. In this case, we'll make it abstract. In this example, we'll be using a concrete subclass, mom and pop shop, to represent a local store. As we can see, it extends the business class. We also have an abstract person class to represent people. Has a height, weight, first name, last name, and several methods already provided. And we also have an implementation of this class called employed person, which represents a person that's employed. And we can see it extends person. We have an interface called taxpayer. This interface declares a method signature with the name of pay taxes. Businesses and employed persons both pay taxes, but are not a type of tax. So instead of inheriting from a tax abstract base class, they can implement the same functionality by implementing the interface and deciding the best way of paying taxes. The tax collector class will collect taxes from everything that owes tax, people and businesses. Let's implement the interface taxpayer to our classes. And here Eclipse is going to ask us to add the unimplemented methods. We'll make a small comment here. And as we see here, we have the SSN, so we'll return that for the get tax ID. Now we'll implement the interface on the mom and pop shop, as most businesses also have to pay taxes. Again, Eclipse will ask us to implement the methods. And we'll return the business EIN. Now, taking a look at the tax collector class. Here we have an array of taxpayers: an employed person and a business, the mom and pop shop. We're going to give him a name of Billy and his SSN. And we're going to call this a tag of coffee shop and a corporation ID. We'll use this variable, taxes collected amount, to be the last and final collected amount of all taxes. We're going to loop through each of the taxes, and we're going to add it to the taxes collected amount. So the tax collector class will create an array of all taxpayers, then invoke via the interface method, pay taxes and collect all the monies due. Let's run our program. This concludes our discussion of Java interfaces. In this video, we will review static data, methods, and blocks. Let's discuss the use of static keyword to create fields, methods, and blocks that belong to the class rather than to an instance of the class. First, let's learn about static variables. Static variables are the special type of variable which are created during the load time of a class, or we can say when the class is instantiated. Here with the new operator, we instantiate a widget. There are occasions when a variable that is common to all objects is desirable. This is accomplished with the static modifier. Fields that have the static modifier in their declaration are called static fields or class variables. They are associated with the class rather than with the object. Every instance of the class shares a class variable, which is in one fixed location in memory. Any object can change the value of a class variable, but class variables can also be manipulated without creating an instance of the class. Let's look at our widget class. Using a static variable to keep the number of widgets the system has created can help us determine availability of stock or control the number of widgets we want to create. Here we have a private int ID and we have a private static int number of widgets. The constructor, when called to initialize the object, increments the number of widgets and assigns it to the ID. Here we see that it's adding to the number of widgets incrementally, but only adding the value of the number to the ID. We also have this method here that gets the ID. We also have a method that is static which gets the available widgets. Static blocks are the blocks which are implicitly called when the class is instantiated. That means when the instance of the class is made. Let's add a static block to our widget. This static block is executed when the class is loaded or initialized, to be precise. It can be thought of as a class constructor. Note that there are also instance initializers, which look the same, except that they don't have the static keyword. Those are run in addition to the code in this constructor when a new instance of the class or object is created. Static methods, such as getAvailableWidgets, have a static modifier in their declaration, and these should be invoked with the class name without the need of creating an instance of the class, as in here, widget.getAvailableWidgets. As we can see, we're not using the instance name w1 or 2. We're just using the class name and then calling the method from the class. Some points about static methods are: static methods are automatically created during the load time of the class. They are accessed by using class name. A single copy of static method is created and shared among all other methods. The most important point: static function cannot access non-static methods members. Now let's run our program and see how many widgets are available. As we can see here, the static block was executed first. Then we were able to get the amount of widgets created, 1 and 2. This concludes our discussion of Java static data, methods, and blocks. In this video, we will review the Java wrapper classes available within the Java programming language. You should already have had exposure to the Java wrapper classes in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. Let's take a look at Java wrapper classes. Java wrapper classes are used to represent primitive values when an object is required to represent the primitive type, and hence plug into an object hierarchy. The wrapper classes are extensively used within the collection classes in the java.util package, and with the classes in the java.lang reflection package. Here are the primitive types above, and here we have the wrapper classes. Since you already know how to use this, here's an advanced performance tip. Wrappers have some overhead associated with them. They offer generality at the cost of inconvenience in digging out the value, and there are some space costs as well. When the need arises to use your value as an object, use wrapper, this method, wrapper.valueOf, because it uses a pool of wrappers, which for performance reasons is preferred over new wrapper. The most common used methods of those classes are the various parse, value, and valueOf methods, because those methods let you turn a string into a primitive. Here, let's do an example of these methods. This method will parse a string Here we're going to wrap a primitive value into an integer. And here we're going to get the value of a wrapper class and place it back into an integer reference of primitive type. This concludes our discussion of Java wrapper classes. In this video, we will review the Java I/O available within the Java programming language. You should have already had exposure to the Java I/O in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. The Java NIO 2.0 has come forward with many enhancements. It's also introduced new classes to ease the life of Java developers when working with multiple file systems. JDK 7 has the addition of file change notifications. This feature, part of NIO 2.0, the Watch Service API lets you receive notification events upon the changes to the subject, the directory, or the file. The steps involved in implementing the API are to create a watch service. Here we have a watch service, we have a path, and we register the watch service with this path. In this case, I'm using ctemp temp. Here's an example. Let's create the directory monitor class named dirmonitor, whose responsibility is to monitor a particular directory. Let's create our watch service. As you can see here, we create a watch service. This service consists of a queue to hold watch keys. These are the watch keys here: entry create, entry delete, and entry modify. While registering, we specify these events that we want to receive. We have to start an infinite loop so we can listen to these events. When an event occurs, a watch key is placed into the queue. We're going to be consuming the watch key and invoking queries on it, such as what kind are they? Let's run our program. At this point, our programming is just listening to the file or directory that we specified in the path, temp.temp. Now what happens if I place a new document in here? We get an event on new text document, number 2.text, entry created. Now we have event on new text 2 is entry deleted. This is a very useful API that JDK 7 has introduced. This concludes our discussion of the Java I/O.